So get this. A quest for telepathy, sparked by a near-death experience over a century ago. That one moment is what kicked off the entire journey to where we are today, on the very edge of designing a brand new layer for the human brain. We're going to trace that line, from that bizarre beginning all the way to the future of the mind. This one sentence, it basically explains a lifetime of obsession. Picture this. It's 1893. A young German soldier, Hans Berger, has this awful accident, a real brush with death. And miles away, his sister feels it. She has this sudden, terrifying certainty that he's in mortal danger and makes their father send a telegram. That single, unexplainable connection is what set Berger on a path that would completely change neuroscience forever. So that brings us to our first chapter, a quest for telepathy. Berger became absolutely fixated on this idea. He was convinced there had to be a physical reason for what happened, something he called psychic energy. He believed the mind had to be producing some kind of wave, and he spent his entire career trying to find it. And this timeline, it really puts the whole thing into perspective. Just look at these dates. From that accident in 1893, it took him over 30 years just to get that first ever recording of a human brainwave, the EEG. Then it took another 14 years for the scientific world to even take him seriously. And then this massive jump all the way to 2024, where we have the first Neuralink patient playing chess using just their mind. It's just a wild timescale. Here's the real kicker. Berger never found telepathy. What he found instead was something so much more profound, the faint electrical rhythm of the brain itself. But when he finally published his life's work, the scientific community, well, they pretty much laughed at him. He was this outsider looking for a ghost in the machine, and he accidentally discovered the machine's operating system. Okay, so Berger proved the signals were there. He opened the door, which brings us to our next big question, listening to the brain. For the next 100 years, the puzzle was, what are these signals actually saying? And more importantly, how can we eavesdrop? And you might be thinking, well, hold on. If the brain is electric, why can't we just, slap some sensors on our heads and read our thoughts? And yeah, that seems totally logical, right? For decades, that's exactly what we did with Berger's invention, the EEG. But it turns out listening from the outside is, well, it's not that simple. This ballroom analogy is absolutely perfect for explaining the problem. Using an EEG is like standing outside a massive ballroom where a billion people are all talking at once. All you can hear is this dull collective roar. You might be able to tell if the party is getting wild or if it's dying down, but can you pick out a single conversation? Not a chance. You have no idea what anyone is actually saying. So what's the solution? Well, to hear the conversation, you have to get inside the ballroom. And that is the fundamental difference. An EEG listens from the outside, but invasive brain-machine interfaces, or BMIs, from companies like Neuralink, they are walking right into the middle of the crowd. By putting tiny electrodes right inside the brain, they can listen to individual neurons with stunning clarity. The signal goes from a noisy mess to crystal clear. And this right here, this is the absolute state of the art. We're talking about thousands of threads, each one thinner than a single human hair, being carefully inserted by a surgical robot, because no human hand could ever be that precise. And the craziest part is, this isn't a one-way street. It doesn't just read brain signals, it can also write back, stimulating individual neurons directly. Now, obviously, robotic brain surgery is, well, it's a big deal, and it's not going to be for everybody. But what if there was another way to get inside that ballroom, a less invasive way in? This is where a company called Synchron comes in with a seriously clever approach. Instead of drilling, they use the body's own highway system, your blood vessels. They thread this device, called a stentrode, up through a vein in the neck and basically park it in a major vein right next to the brain's motor cortex. It's genius. It's a way to get inside the party without having to knock the door down. Okay, so Neuralink and Synchron are both incredible, but they both run into the same fundamental problem. Your brain is smart. It recognizes a foreign object, and over time it builds up scar tissue, which can disrupt the signal. That brings us to a radical new approach, the biohybrid solution. The idea is to stop fighting biology and instead join it. Just stop and think about what the brain actually is. It's this impossibly dense, soft, living network. There's just no empty space in there. So trying to shove rigid foreign electronics into this delicate tissue is always going to be a huge challenge. The brain's greatest strength is also the biggest hurdle. So the key to this next big leap is a revolutionary technique called optogenetics. And this is seriously cool. It's a way to genetically engineer specific neurons so that they become sensitive to light. You shine a tiny light on them, they fire. Turn the light off, they stop. It gives you this amazing level of control without any physical wires. And this is where things get truly mind-bending. A company called Cybercortex, founded by a Neuralink co-founder, is developing a biohybrid interface. Instead of just inserting wires, they start with living neurons that are engineered to respond to light. They put these neurons on a tiny chip with micro-LEDs. When this chip is implanted, something amazing happens. The new neurons actually grow out from the chip, like the roots of a plant, and form natural synaptic connections with your brain's own network. It's not forcing a connection, it's growing one. The implications here are just massive. If you can successfully integrate a living electronic device into the brain, you're not just talking about controlling a cursor anymore. We are talking about adding a completely new designed layer to the mind itself. A new layer of mind. To really grasp how revolutionary this is, you gotta remember our own brains evolved in layers. The newest edition, the neocortex, is what gives us things like language, planning, and abstract thought. It's basically what makes us human. So what happens when we don't have to wait for evolution to add the next layer? And that's where this concept of the cybercortex comes in. It's a potential new layer of the brain, but one not formed by millions of years of evolution. It would be formed by design, a seamless digital bridge between our biological minds and the world of computation. The founder of Cybercortex, Max Hodak, uses this incredible analogy from the movie Avatar. He imagines a future where this tech allows for a direct synaptic link, not just to computers, but maybe even to other minds, a true biological internet. Which leads us to the ultimate science fiction endgame of all this technology. It makes you wonder, if you can perfectly read sensory information from the brain and perfectly write new information back to it, what kind of world can you create? What does it mean to be building a new reality? The logical conclusion is basically the Matrix, a fully immersive virtual reality that isn't streamed to a screen but is generated directly in your consciousness. Because all of our reality is just electrical signals interpreted by our brain, a perfect interface could just feed it a whole new set of signals, creating an experience you couldn't tell apart from the real thing. And this quote from Max Hodak just perfectly captures the sheer audacity of this whole field. I don't know if we are living in a simulation, but we should build one. I mean, wow. It's such a bold statement about actively shaping the future of what it even means to be human. So we started this journey with a soldier in the 19th century hunting for telepathy, and we've landed at the very real possibility of a man-made reality. The entire story of the brain-machine interface has been about learning to speak the language of our own minds. Now that line between biology and technology is getting really, really blurry, and it forces all of us to ask, what kind of future do we actually want to build with this incredible power? This whole explainer was based on the chapter called From Telepathy to the Cybercortex in the book Simulated Reality. If you want to dive deeper into all this, we've put information about the book down in the description. Thanks for watching.